What is going, guys? Welcome back. In this video, we'll be talking about the rational theorem. The whole goal of this video is to really talk about the rational theorem by stating it and then talk about what it means. And then we'll do an example problem to finish it off. So let's just hop right into it. Okay, so the rational theorem says, okay, well, if we have a polynomial, which is in the form a1 x to the n plus a2 x to the n minus 1, adding all the way down to a constant term, a is a 0. Well, and if we want to find the possible roots of the function are in the form p over q, where p is all the factors possible of the constant term of the polynomial. So this a is of 0, and q is the factors of the leading coefficients. So this a is of 1. Okay. So what that means is, okay, well, if we say we have a polynomial 3x squared plus 4x plus 6, all right, and we take our p over q, all right, we wouldn't simplify it down, but we want to find all possible roots, potentially to have a 0 in it. So we list out every possible factor. So for p would be 6 and q would be 3 in this case, and we write out all the possible roots. All factors in each number. So in the 6, it has plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And q is plus or minus 1 and plus or minus 3. All right, so then we apply factor theorem. All right, which states pretty much if we could divide if x minus c divides into if x minus c divides into f of x, and so pretty much it's a factor of x, of f of x. Okay, so pretty much if we divide the polynomial, and by some term, so x minus c, if we divide our polynomial by x minus c, then and it divides evenly, it's a factor, all right, with no remainder. So we cannot have a remainder. Sorry about that, guys. Let me fix that so you guys can see it. No remainder could be had. All right. So in this case, we'll be like, so a common problem that we see with it, will be find all the possible roots for the function down below. F of x is equal to minus 3x to the 4th minus 18x cubed plus 9x squared plus 168x plus 144. So the first thing I always do is I look at all the terms, and then if there's a common factor between them all. All right, so we can't factor out any x's in this case, but we can factor out a minus 3 because every factor has a form of minus 3. So pulling out a minus 3, we have x to the 4th. So we have positive x to the 4th, and then we get positive 6x cubed minus 3x squared minus 56x plus 48. So then we take this polynomial. So we take, I always underline it here. Okay, I always underline it right there, and then I say, okay, well now we're going to apply the rational theorem. All right, so by rational theorem, we're going to do p over q. So our constant term is 48 in this case. So we don't really care about the sign. We just take the number 48, and then our leading coefficient's 1. Okay, so we list out all the terms that could go into 48. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, plus or minus 48. And our q is 1, so plus or minus 1. All right, so then it simplifies out to every possible root to being just this numerator up here, okay? Plus or minus 1, plus or minus 2. So all of our possible roots are, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 plus or minus 6 plus or minus 8 plus or minus 12 plus or minus 16 plus or minus 24 plus or minus 48. Okay, so these are all the possible roots. Now it's a guess or check. So now if we divide out by any of these factors, any of these possible roots, any of these numbers, if we divide by a factor of it, well, and we get a remainder, we say, okay, well, it's going to be it's going to be a factor. Well, so this is where it gets really tedious, because you got to check every single number. All right, hopefully, and hope you don't get a remainder. So in this first case, I chose -1. Okay, so choosing -1. All right, so we apply synthetic division. So putting -1 on the outside. All right, we put -1 down. All right, so we bring the 1 down. Okay, multiply. So so -1 times 1 is -1. We place it here and add. That's 5 left. Okay, multiply again. So -5 times -1 times 5 is -5. Then we add. -3 plus -5 is -8. Do the same thing one more time. -1 times -8 is 8. -56 plus 8 is 48. And we do it one more time. -1 plus minus times -48 gives us positive 48. So, and that gives us a remainder of 0. So therefore, we have a factor. So this x minus 1 is a factor. In fact, it'll be an x plus 1 in this case. All right, it'd be x plus 1 because x minus 1 is a factor. Okay, and so that leaves us, and so then this translates to a degree lower. Okay, this becomes our new polynomial, x cubed plus 5x squared minus 8x minus 48, and we apply it again. All right, we keep doing this until we get into a form to where we could factor it cleanly, ideally a trinomial. So we have rational theorem again. Plus or minus 48 is our p. Our q is 1. So that leaves us with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, plus or minus 48. Okay, and then so I said, okay, let's try positive 3. Okay, well, all right, so that one's wrong, but okay, so I just chose one, and I said, okay, let's choose positive 3. And since I know 1 most likely won't work, so you just choose a number. So 1. So you bring the 1 down. Once again, using synthetic division. 1 times 3 is 5. All right, sorry. 1 times 3 is 3, and we place it here. We add, giving us 8. Multiply again. Gives us 24. Add gives us 16. Multiply 3 times 16. Place it in here. Gives us 48. Add, it gives us 0. So we know it's a factor because we don't get a remainder. So now that gives us a polynomial where it's x squared plus 8x plus 16, and that factors really cleanly, because if you see here, it's a perfect square. All right. So x plus 4 times x plus 4 gives us this trinomial, this quadratic. Yeah, pretty much we get, okay, well, so now that it's factored, we get minus 3 times x plus 1 times x plus 4 squared times x minus 3 is equal to f of x. All right, so now setting it all equal to 0. All right, so we set it equal to 0. And x minus 3. Okay, so is equal to 0. So we divide out by -3. So you guys can see that. We divide by -3. Keep leaving us with x plus 1 times x plus 4 squared times x minus 3. Okay, so x plus 1 is equal to 0, leaving us with -1. Alright. Give me a second, guys. Let me readjust. X plus 4 squared is equal to 0, and x minus 3 is equal to 0. Alright, so taking the square root of both sides, we get x plus 4 is equal to 0, leaving us with x is equal to -4. And last but not least, we have x is equal to -3. We add 3 to both sides. X is equal to 3. So these are all the roots. These are all the possible roots in this polynomial. In fact, when we talk about graphing, in this case, we would do the same steps up to here, graph all the possible roots, and bounce them with multiple, cross and bounce with multiplicities while we're graphing them. With that being said, guys, we'll see you guys in the next video. Later.